Hello, my name is Barry Hickey, and in this short video I'm going to be talking about sections of solids and the different types of section planes that can go through a solid object. The three types of section planes are vertical section planes, simply inclined section planes, and oblique section planes. So vertical section planes are parallel to the vertical plane, or the VP, our principal plane that our elevation is projected onto. They can also, a vertical section plane is very similar to a horizontal section plane, only a horizontal section plane is parallel to our horizontal plane, which would be where the base of our square-based pyramid is sitting here. So what I'm going to do in this video is draw the isometric view of the cutting plane here in elevation and in plan, and I'm also going to go through the traces of this plane very briefly on our vertical plane and our horizontal plane. So to start off with the vertical section plane, I'll draw my elevation of my pyramid. This is the elevation of my pyramid before the section plane has been included. And this is going to be the plan. See these light lines for the plan. Now we want to put in our vertical section plane. So in our elevation we can't actually see this plane, as it is of infinite size both vertically and on the horizontal. But as we can see here, it cuts the pyramid about 10 mil from the corner, from the bottom vertex. So if I bring up my set square and draw a horizontal line 10 mil from my vertex, this will give me the 2 points at where it cuts the edge of the pyramid. So if I bring them up to elevation, we now have we now can see where our cutting plane cuts our elevation. And we can see our cutting plane in plan. So this is our cutting plane, or our section plane. In the graphic I have this denoted with red, so just to keep it the same, I'm going to mark this as a red line. I'm going to heavy in my finished plan now. this is the plan of our object. If we look down from here, this is what we would see. Now we can fill in our elevation. The elevation doesn't change shape because it is a vertical plane, so it will stay parallel. We just have this line to show where our cut edge starts. So I'm going to draw in my hatching. And I'm going to denote these sides the same colours as I have in the graphic. This is green, this edge. And their back edge is dark green. Now our two side edges in plan are lighter green. So this is our vertical section plane. I'm going to draw in limits of this plane in elevation just so we can compare it to the graphic above. In the graphic, this plane was yellow. I'm just going to roughly give it the yellow shade to so that's our vertical section plane. Now we'll move on to our simply inclined section plane, which is similar. The simply inclined section plane runs either parallel to the one, its vertical traces are horizontal and its horizontal trace are horizontal when we look at them in our elevation and plan. So what we want to do is we'll draw again our elevation and draw in our section plane. So now we have our elevation and our plan of our square base pyramid before our cutting plane is added. So our cutting plane, I'm going to draw it at 30 degrees here. And our horizontal trace will look like this. It's at 90 degrees to the vertical plane. So as we can see, it cuts in two places. So we want to bring down these 2 points. That cuts both of these edges. Point 1 0.2. Here we have 0.3 and 0.4. So to finish off our drawing, we want to connect up point 1, 2, 3 and 4. And I'm going to hatch this area . We can see our cutting plane is at 30 degrees. So we'll mark it like so. And our elevation. So anything below the cutting plane remains. So anything above it is drawn with a dotted line. This is our elevation and our finished plan once I heavy in. This is our completed elevation and plan of a simply inclined section plane. And I'll just label my traces. This is the vertical trace and this is the horizontal trace. Okay. So now on to the oblique section plane over here. I find the oblique section plane the most difficult to visualize, as it isn't parallel to either the vertical plane or the horizontal plane. It has no its traces are not parallel to either the vertical plane or the horizontal plane in plan or elevation. So to draw this, we first again we'll start with our drawing our pyramid. Down these points. Sorry. Okay, so once we have our plan and our elevation of our pyramid drawn, we now want to draw our oblique plane. Usually when we are drawing our oblique plane or completing questions with the oblique plane, we're given its angle to the vertical trace and the horizontal, or the vertical plane and the horizontal plane. So for this example, I'm going to draw mine at 30 degrees and at 60 degrees. And 60 degrees. I have completed another video in order to find the oblique plane and the cut solid once the oblique plane has been used. It requires an auxiliary projection, which can be an auxiliary elevation, which can be seen in my next video. Thank you.